let's have a look at the Python setup. So today we're going to go through the different recommendations for the installation and to go through one of the examples. And next day we will go through the more advanced things that we can do with it. Just one recommendation is that in order to do all this, since you're gonna get a lot of extra functionality, and it's quite an advanced framework, but you have to be somehow a little bit familiar maybe with the command line, or at least willing to learn. It's not a complicated thing to do, but there is a little bit of a learning curve to go through it. So we recommend Python 3.8. 3.9 is also good. I wouldn't recommend you go to the latest version of Python because I think that currently is 3.10 or 3.11. I'm not sure. But don't go to the last one because a lot of the libraries haven't adapted yet their installation setups so that they are adapted to the new Python versions. So I would encourage you to stay with a stable version that is maybe 3.9 or 3.8 as here. So to install it, Python is available for any distribution or any platform. So you will find it easily on Windows or OS X or Linux, of course. And in our documentation and also on the MINKE documentation, you will find how to get started. Now, to install Python itself, we recommend that you follow the guide that is included in the documentation, which will go through the different steps that you have to do for the different, let's say, platforms. And I guess that a lot of you will be using Windows, so I will give you some recommendations in particular for Windows. But one important thing is that I do not recommend that you install Python with an app. So if you open any app store like Apple App Store, or I think Windows already has an app store now, I wouldn't recommend that you click on a simple executable file that installs Python, but that you follow the recommendations that are given in these installation guides. Because Python is probably a little bit tricky sometimes to install, so please go through those guides, and I will give you couple of recommendations in a second. Then for actually accessing Python and working with it, we use an IDE, which is similar to RStudio. So it's very similar to this, but in this case, it's called JupyterLab. So it's a web interface that provides you with a very easy interactive way of programming and create what we call notebooks, which is a type of file that is smart in a way that you can run commands inside the file, and in particular run Python scripts or other programming languages and get the output on the document itself. And you don't need to use a command line or anything like that, and it's running on any browser. So to install it, you will use, or you can follow these guides. I would recommend you use pip. Pip is the standard way for installing packages in Python, and JupyterLab is simply another Python package. So you can just type on your command line pip install JupyterLab, and you will see a lot of outputs on the command line, and you will get JupyterLab installed. And I'll show you how it looks in a second. Then for the data analysis part, you can do the same for our data framework. So simply doing pip install sc data, you can install the framework the same way that you installed JupyterLab. So just to show you very quickly the project page. It's available on PyPy, which is the Python package inventory or repository. And here you can see the description and how to install it. If you also want to work on the source code and improve it, you can download it and install it, and then work on the code by installing it in an editable way. Finally, well, here, little by little, you'll see that we have a lot of things that we can do with it. And we will talk a little bit more about it on the next session. But there's a lot of configuration that you can do, for instance, to be able to upload the data to Zenodo, or to store the data, or configure the way that you interact even with our API. Just for clarity, this is also the GitHub page of the project, in case that you want to contribute and have a look at the source code itself. So installing SC data the same way as JupyterLab. And finally, if you want to get a way for documenting your projects, and actually this is a requirement on the MINKE open calls in the low-cost sensors data, you can install JupyterBook. So JupyterBook will allow you to create a very simple Markdown interfaces, so that you can create books are called. So this is, for instance, sometimes that you can create with JupyterBook, which would be website already available and accessible online, that is very easy to create with a couple of commands, and you don't have to worry about any customization or CSS or HTML programming, which can detail the different steps that you followed on your project and have a small digital presence, as we call it, so that you can showcase your project. So you can include different Markdown pages, but also, more importantly, within that is interesting that you have a way for you to show the data and the analysis that you conducted with the code in it, so that people are able to see the data analysis that you performed. So not many people do this this way. Normally, data sets are available upon request, especially on research. Now we are tending to a more open approach, sending data to open repositories like Zenodo or similar. But we think that this is a very good way for sharing data, and sharing not only the data itself, but the analysis that was conducted, so that others can download the same processing that you did and run the same scripts or code that you worked on. Here, there are different examples on how you, for instance, can plot the data, and even in an interactive way. So you can zoom in and have a look at the data itself on a web framework. That is quite a nice feature, considering that all this is generated in a very simple way, with not that much work, considering the amount of data that there is. So if you want to use this tool for that, you can install what we call JupyterBook, and it's the installation is detailed here, but it's the same. So it will be pip install JupyterBook, and you are good to go with it. So some recommendations, and maybe before next session, it will be good that you run through some of the installation process and try to run some of the examples on the Python setup, if it's the one that you're going to choose, so that on next session we can go through and understand what the problems are. But I recommend that you follow the guide that it's provided on the website before, and do not install python.app or python.exe on Windows or OS X. In Windows, we recommend that you use PowerShell, which is normally is pre-installed, but if not, you can install it from, in this case, the Microsoft App Store. And then you will use it as a terminal with admin rights and install this program called Chocolati as a package manager, with which you will be able to install Python. This is the best way to do it, so that you have access to all the functionalities and you don't have such much hassle to install everything, especially because in Windows traditionally has been a little bit more difficult to install these things, since there is no package manager as in other distributions or platforms like in Linux. Finally, to install all the rest, so SCData, JupyterLab, and JupyterBook, pip is probably the easiest. You don't need to use Anaconda, but if you want, you can also use Anaconda, which is an already prepackaged distribution of Python with an environment manager that is easy to install, but it's probably including a lot of extra overhead that you don't need. So let's have a look at all this in an actual setup. So this is basically the notebook interface. So this is JupyterLab that you can see that is running on my browser. The interface is composed of this main window, which contains what we call the notebook. And the notebook itself is comprised of different cells. So each of these blocks is what we call a cell. And there are some cells that are simple text that you can write whatever you like in here. And some other ones are code cells. So the ones that are text, you see here that are marked as Markdown. Markdown is a type of markup language for text, and the other ones are running as code. Here on the right side, you see that we're running Python 3, and on the top here, you see different buttons. So you see, for instance, a play button that would allow you to run the cells. If you get used to this interface, you can press Shift Enter, and you will run the cell as well. So in this example, what we do is we load different data, and you can see that as soon as I run a cell, especially when it's a code cell, there's a small star on the left side that is basically indicated that right now we are running that cell, and that is executing some code. Here on the top right, you also see that what is called the kernel, which is it's Python in this case, is BC, because this circle here is filled in gray. As soon as it's done running, it will become white, as you can see now. And then this small asterisk or the star that you saw here, before it was run, there was nothing, and now there is a number indicating that that is the first cell that we run in this notebook. So if you go down and run another one, it will have number 2, and if I run it again, it will have number 3, and so on and so forth, indicating that I've run that cell as many times as this number indicates. So on the left side, in my case, I am right now on the examples folder of the GitHub repository. So you can download the repository if you want and work through the different examples. And here you see that there's a lot of notebooks that you can access to access the functionality of the framework itself. But today we're going to focus on two brief examples on how to run the framework. So as soon as you have everything installed and you open any of the notebooks, you can always run the first cell. And if there's SC data on the cell, either as an import, for instance, import SC data as SC, or from SC data import something, if you don't get an error, it means that the whole installation process was okay. So here, for instance, you can run sc.version, and in my case, I'm getting version 0.7.0, which is the latest version. If you run this command, you should see a similar output as well. Now, we're going to start loading data, and we will see different ways to access it. The most interesting way to access the data is what we call a test. So earlier on this interface, we only accessed one device, and each device has to be called with the same methods as many times as needed in case that you want to load the data in another way. But the test is basically a way for us to get a lot of devices in one object, we could call it, that contains already information about what we are doing as a concept. So imagine that we are running an experiment with 30 devices. In the test, we can include all 30 devices, and that way, anytime that we load the test, we load all 30 devices, and we don't have to load each device each time. So I'm going to create a test that is called example. And this time, well, as you can see, I have a lot of examples. You wouldn't get this output in your particular case, but I'm gonna, just for the sake of the demonstration, load this test, which we'll see in a second what devices it contains. And skipping that for a second, I'm gonna just load this test. And here you see that there's a lot of output. But the most important thing is that you are loading different devices within this test. And that is giving you all the information that we saw earlier on the JSON, on the API, but in an ordered way. So we are getting where it's located, what sensor it has, and different functionalities. So we can also configure, for instance, if you want to convert units and so on and so forth. Now we have all the data loaded. I'll show you in a second how to create these tests. But in here, I have data from 3 different devices. So 2 devices that come from the API and another device that comes from CSV data. And as simple as that, I am able to load 3 devices, 2 from the API and 1 from CSV or local readings without much hassle. So for instance, I can access the data from this device here and have a look in a table. And I see that I have 90,000 rows, which is probably around 2 months of data in a minute resolution, just like that, which is very powerful. So considering the amount of data that we have in here, the time that this took to run is very, very little. So this is, as you can see, a very powerful way for you to access the data. Now, how do you create these tests, or how can you access the data itself? So in here, I created this test called example, and let's just create one for this particular case, example MINKE. And you see here that, oh, there was another one already. Let's create that name. Okay, so now we have a test that is example MINKE demo. And each test is going to have different devices. So we are going to add a device one by one to the test. So for that, we import the device object. And then we will add, with this simple method, add device to this test. So we will create a device that is coming from our API that has this ID, and that is what we call a station, and we add it to the test. We can also add another device, for instance, this 14627, or in this case, we can add another one that is coming from a CSV file. So this last device here is not coming from the API, it's coming from a local file, and the name of the file is called example.csv. This file is located in this folder here. So let me just show you where or how does that look. So here you see, for instance, how that example.csv file looks. This is one data file coming from the kit, but it's not just one day. It has, if I am correct, no, it has only one day. On the next session, I'll show you how to load more than one day and how to concatenate more than one day on the same file. But here you see that we have roughly 1,000 lines of data, and probably that is not that much, but if you start concatenating days on the same spreadsheet, that is probably gonna take a long time. So I can add that device as well to the test. And one important thing is to define here the time zone. The time zone is important because the SD card doesn't know where that data is located. You have the data in UTC format, and it's important to define at least a correct time zone for the data coming from CSV files. Otherwise, you will have the data shifted in case that you have data located in wrong places. So as soon as I have that the device is added, I can create the test. And you see that it's processing the CSV file, is creating the test itself, and then we can load it again. So now we are requesting the data to the API, and we will load the data from the CSV file as well. So you see that all this data has been loaded and that the load was completed. So now in the test, we have these two devices, okay? And the data, we can still have a look at it in the same way as before. Now, the example here will walk through different aspects that you have to understand to be able to load the data and work with it. Basically, what we are doing here is creating something that is called blueprints, which basically defines all the recipes and items items necessary for us to load the data and to process the data. So each of the devices that you load has to be associated with what we call the blueprint, so that you are able to know where the data is located, how to request it, what type of sensors it has, and so on. So that is located in this object. It's called in config.blueprint. And here you see that there are different types of blueprints that you can define. For instance, if we look at the Smart Citizen Kit 2.1 blueprint, you can see that it has the documentation, it has different sources that comes from CSV or API. It has different metrics and sensors with units and different processes. And the idea is that here is a way for us to define what type of operations we do when we load a device and when we say process that device. For instance, the different sensors here, we see that we have the battery, the ECO2, volatile organic compounds, humidity, particulate matter, etc., with units and small descriptions. And then the metrics, which are the type of calculated channels that we will create once we process the device. So we can define here functions and different types of data processing flows that will perform operations on the different channels and create what we call metrics. These metrics can be as simple as cleaning data or performing, for instance, sensor calibration or similar. So to finish with this initial demonstration, I will list again the different devices, show you the way that you can access the data itself, and the different metadata, for instance, that we have stored on the test itself. So the test contains the devices, contains all the information that we described, and importantly, it allows you to have some sort of traceability on what that data capture was. And for instance, we want to do the same thing as we did before. For instance, for in R to store the data, we can export it for instance, on my desktop. And this will create a CSV file with the name of the device. And probably this will take a little bit longer. And here on the right side, you see that that is quite a small handle. But for instance, you see that we have 90,000 rows in here. So already Excel or any other program probably will be struggling to handle this data. But in Python, you see that it takes very little time to load it. Also, you can start creating some things, for instance, creating small reports or small interfaces in HTML that you can then customize and use to showcase. We'll see more on this in next week, but here you have a small HTML interface that then you can like embed on a website with all the metadata and all the different channels and information that you have on the device. And you can also export all the devices to CSV.